I welcome all the students to this lecture of fluid mechanics, in which we are going to discuss how to find out a force on a plane surface when it is in contact with the fluid. Then we shall discuss how to find out force on a curved surface. Then we shall try to cover the stability of partially submerged and fully submerged body, which is very important for sea-going vessels, whether it is a submarine or whether it is a ship or boat. So to begin with, in the last class we discussed about the hydrostatic force on a plane surface, and this topic is useful whenever we want to design a reservoir masonry structure. You might have seen in your life dams are made in which masonry structure means made from bricks and earthen material. Now for that we have to build masonry structure across the river to store water on the upstream side. Now to design it very properly, we must know that what is the force coming on the structure due to the contact with fluid. So for that we are going to develop relationship which will give us the force which will be developed due to the fluid on contact surface, and we must know that at which point this force acts through. So we must know these things, that first is the magnitude of the force and second is the point of application of the force. Now this thing we discussed in the last class, and the formula is developed on the basis of that under equilibrium condition summation of forces must be equal to 0, right. So for that we had a pressure force at different elemental strips. Since elements are lying at different height of the fluid, in that case pressure is varying. If pressure is varying, and we know the relationship for pressure, that is P is equal to gamma into H, or maybe further expanded P is equal to rho GH. So we take the force on a small elemental strip and then integrate over the area. So we get that net force is equal to rho GSC into A, where SC is the height measured from centroid of the area to the liquid free surface. In this figure, if this is the C, centroid of this cross section, then this perpendicular distance measured from centroid to liquid free surface in perpendicular direction is called SC. Now to know that where this force is applied through, this is the net force, but it does not act through the centroid itself. So to know that, we have to develop a relationship in which distance will be there, right. So first we assume that this force, resultant force, is acting through this point, and area is symmetric about y dash. Then area is symmetric about y dash, then naturally the force will apply about the on this line. It will fall on this line because area is symmetric, right. So what we do, we take a moment of the resultant force about OX, and we take the movement of the forces produced by the force acting on the small elemental strip. Like in this case we take the force here and take the movement of this force about OX, and under equilibrium condition these two must be same, means movement due to the resultant force and movement due to the force acting at a small elemental area must be same under equilibrium condition. So on the basis of this proposition we will develop this relationship, and by using the concept of second moment of area we can write this y bar is equal to I x dash divided by yca plus yc, where I x dash is equal to moment of inertia about this axis which is passing through centroid of the area and parallel to OX, and yc is the distance measured in y direction for this figure from O to C, centroid of the area. So, all these things are positive, it means that y bar will be positive. And what is y bar? Y bar is the distance measured in this direction from O to F, this point, and this point is also known as the center of pressure. So, center of pressure is a point through which the net force acts through. So, with the help of these two formulas, F is equal to rho g SC into A and y bar is equal to I x dash divided by yc A plus yc, we can calculate the resultant force and we can find out the point through which it acts. If this surface were not symmetric, then we would have been calculating the x bar also. On the same principle, we can calculate the x bar. In that case, we have to take the moment about OY for getting x bar distance. For getting y bar distance, we have to take moment about OX, and for getting x bar, we have to take the moment about OY.